Alright guys, today we are having solving algebraic equations review. Our objective is I will understand how to solve algebraic equations involving addition, multiplication, subtraction, division, and fractions. So inverse operation, which is what we are working currently with, so we need to know what the inverse operation for subtraction is. Well, the inverse operation for subtraction is addition. Looking at number 2, it wants to know what the inverse operation for addition is. Well, if we know the inverse operation for subtraction is addition, so the inverse operation for addition is going to be subtraction. Looking at number 3, it says the inverse operation for division is, well, the inverse operation for division is multiplication. Oops. Write that one more time. And lastly, looking at number 4, says the inverse operation for multiplication is, well, if we know that the inverse operation for division is multiplication, then the inverse operation for multiplication is going to be division. All right, we're going to review this problem together as a class. It says 12 plus u equals 65. Well, first thing we must do, we've been working with this past week, is we must first find the inverse operation. The inverse operation. And we know that our 12 is a positive 12, so the inverse operation for addition is going to be subtraction, so we need to subtract 12 from each side. And whatever we do to one side, we have to do to the other side. This cancels out our 12 on this side, which leaves us with u equals, well, now we have 65 minus 12, which gives us 53. So u equals 53. And remember, we can check our work by substituting the value in for the variable. So our equation was 12 plus u equals 65. Well, we just solved for the value of our variable. Our variable was u, and the value we found was 53, so now we can substitute it in. So 12 plus 53. Well, 12 plus 53 gives us 65. So we know we did our math correctly because we got 65 as the outcome. And this is where we made that connection of substituting the value in for the variable. Moving on to question number 2. It wants us to solve for the value of our variable, find the value of our variable, which it says 10 times u equals 120. Well, the very first step we must do when solving algebraic equations is find the inverse operation. So if we have 10 times u, the inverse operation for multiplication is going to be division, so we need to divide by 10. And whatever we do to one side, we have to do to the other side. Well, this cancels out our 10s, which leaves us with u equals, well, 10 divided by 120 gives us the answer of 12. So u equals 12. Remember, we can check our work by substituting the value in for our variable. So our value was u, and the value of our variable was 12. So if we had our original equation was 10 times u equals 120. Well, we said that u equals 12, so now we have 12, or 10 times 12. Well, 10 times 12 equals 120. So since we came out with 120, we know we did our math correctly. And this right here in the blue is where we made our connection of substituting the value in for the variable. Moving on to our next problem. This is a two-step problem. And remember, when working with two-step problems, we have to get rid of the number that does not contain the variable first. So looking at this problem, can you tell me which number does not contain the variable? What number does not contain the variable? Good. So if you said that the 1/6 does not contain the variable, you are correct. So we need to find the inverse operation of 1/6 first. So since the 1/6 is positive, we need to subtract 1/6. And whatever we do to one side, we have to do to the other. So we need to subtract 1/6 from the half, which we get to cross these ones out. And I'm just going to rewrite the 1/2 minus 1/6 right down here. Well, now we need, since we are subtracting fractions, we need to make sure that the denominator is the same so that we can multiply or subtract right across. So I know that 2 times 3 will give me 6, which means whatever I do to the denominator, I have to multiply by the top. So I need to multiply the top by 3 as well. So when I multiply those two, 3 times 1 gives me 3, and 3 times 2 gives me 6. And our other fraction was good because it was 1/6. The denominators are the same. So now we can subtract right across, which when we do, 3 minus 1 gives us 2, and our denominator is 6. So now we have found 2/6. Now I'm going to rewrite our the rest of our equation, which was the positive 6x equals 2/6. Well, looking at this was right up here was our first inverse operation. Well, it's a two-step problem, so we need to figure out what our second inverse operation is going to be. So if we know that 6 is being multiplied here, we need to do the inverse operation. And the inverse operation multiplication is division. So we need to divide by 6, which gets to cancel out our 6, which leaves us with x equals, well, whatever we do to one side, we have to do to the other, which gives us dividing 6 over 1, because we need it to be a fraction. Well, remember that acronym, 3-letter acronym, the KCF, keep, change, flip, which we learned that flip means to do the reciprocal. So we need to use that acronym here. So we need to keep our first fraction, so 2 over 6, change our middle operation from division to multiplication, and flip our last fraction, which also means to do the reciprocal. So instead of 6 over 1, it'll be 1 over 6. Now we can multiply right across, which 2 times 1 gives us 2, and 6 times 6 equals 36. And now we can simplify. Well, I know that 2 goes into 2 and 36, which 2 divided by 2 gives me 1, and 2 divided by 36 gives me 18, because we need to simplify our fraction. So x would equal 1/18. And remember, we can check our work. So check work by substituting the value in for our variable. So our original equation was 1/6 plus 6x equals 1/2. Well, now we know that our value was 1/8 and our variable was x, so we can substitute it in. So now we have 1/6 plus, we need to write it as a fraction, so, and we need to multiply, so I'm going to put parentheses around it. So 6 times 1, 6 over 1 times, well, we said x equals 1/8, so 1/8, 18th, sorry. So now we need to multiply first. So 6 times 1 gives me 6, and 1 times 18 gives me 18. And we had that first half of our fraction, which was 1/6. Well, since we're adding fractions, we need to get the denominator the same. Well, I know that 6 is equal to 8. That 6 times 3 will equal 18, so we need to multiply the denominator and the numerator by 3. So now when I rewrite this fraction, we get 3 times 1 equals 3, and 3 times 6 equals 18. It was adding 6/18. Now we can multiply straight across, and I know that 6 plus 3 equals 9, and 18 plus 18, our denominator is going to be 18, because we found the common denominator. Now we can simplify, which when we simplify this, I know that 9 goes into 9 and 9 goes into 18. So 9 divided by 9 is 1, and 9 divided by 18 is 2. So we know we did our math correctly because we got out with 1/2. Now I'm going to highlight where we made that connection of substituting the value in for our variable. Our next practice problem is 2 ninths times f equals 2/3. So the very first step we must do is find the inverse operation. Inverse operation. So since 2 ninths is being multiplied by f, we need to divide 2 ninths by f. So whatever we do to one side, we have to do to the other. So I'm going to write divide 2 ninths, which we get to cross this out, which leaves us with an f equals, and I'm going to write our 2/3 divided by 9, 2 ninths. Remember that acronym, keep, change, flip, KCF. We're going to use that here, which means we got to keep our first fraction, 2/3. We need to change our middle operation from division to multiplication, and flip our last fraction, which means do the reciprocal. So now instead of having 2 ninths, we have 9/2. Now we can multiply across. So 2 times 9 gives us 18, and 2 times 3 equals 6. And now we want to simplify, and I know that 6 goes into 18 3 times, so f equals 3. And that's our answer. Remember, we can check our work, by substituting the value in for our variable. So our original equation was 2 ninths times f equals 2/3. So when we multiply 2 ninths by the value of our variable, which we said was 3, we now have 3/1, which 2 times 3 equals 6, and 9 times 1 equals 9. And 3 goes into both of them. 3 goes into 6 2 times, and 9 goes into 3 3 times. So we did do our math correctly because we came out with 2/3. I'm going to highlight where we made the connection of substituting the value of our variable. Lastly, we have the you try problems. Oops, let me erase that real quick. If you want to go ahead and try solving them on your own, we'll come back and we'll solve it together. Let's go ahead and stop the video and then play it when you are ready to try it together. All right, looking at our first one, we have 54 equals 27 plus O. So we need to get the value of our variable by itself. We have to figure out what the value of our variable is. So since 27 is positive, we need to subtract because it's inverse operation. And whatever we do to one side, we have to do to the other. So we can cancel out our 27s, which leaves us with O equals, well, now we have 54 minus 27, which O equals 27. So you should have gotten O equals 27 as your answer. Lastly, looking at 7 equals G over 5. Well, since 5 is being divided by G, we need to multiply 5. And whatever we do to one side, we have to do to the other. We get to cancel out our 5s, which leaves us with G equals, well, 5 times 7 gives us 35. So you should have gotten G equals 35 as your answer.